Gentlemen, this is Dr. Daria Brzezinski with Children Come First. We're here every Tuesday from 10 to 11 a.m. on your radio dial, WAAT. And we're here this morning with Bob Hammond from FIRST. And FIRST stands for Inspiration and Recognition of Science and Technology. With all of the scuttlebutt these days with the research that has come out, the TIMS research about how we are not doing very well in science and mathematics and technology, I thought this was probably the most appropriate time to talk to an inspirational group that has been doing something incredibly wonderful to promote this with our children. Good morning, Bob.
Good morning, Dr. Brzezinski.
We're informal here. You can call me Daria.
Okay, Daria.
Now, Bob, give us a little bit of background on how FIRST began. Would you mind doing that for us?
I'd love to. FIRST was founded 10 years ago by Dean Kamen, who is a local inventor in Manchester, New Hampshire, which is where we're headquartered. Dean is a very, very advanced thinker and saw the need for the United States to become more competitive developing engineers and doing training in science and technology, and knew that we would be running into a shortage of engineers sometime in the next few years, and that has proven to be true. Dean founded the organization, and it started with a small science enrichment museum here in town, which he then used to bring young people into just see things in the museum. But his main goal was to develop a program where he had high school students competing in robotics. And that program started 8 years ago, and now will involve this year 375 teams from around the country, and we will be competing during the month of March. And the program has proven to be very successful. We are indeed inspiring a tremendous number of students to study engineering, and part of what we do is when we give these students a kit of parts, they have 6 weeks to design and build a robot which will compete in a game that changes every year. And they must work with engineers from corporations, and these engineers mentor the students and help them understand the principles of engineering and build their robot.
Now, I'd like to take a step backward here, because one of the most intriguing prospects for me about this was that I am constantly promoting integrated systems in school. And this combines science, math, and technology, as well as joy, engineering, community, parents. I mean, it's just an incredible program. How did he, Dean, configure on, I mean, he must be really involved in many different corporate levels to be able to pull something like this off?
Yes, Dean is an exceptionally interesting man. Formed his own company while he was still in college, and the company was basically so successful that he needed to drop out of an engineering school, and he went on to form several more companies. He has developed very, very strong relationships, and his principal operation now is developing very advanced medical products. But again, he works well with young people. He is an exceptionally motivating person. The program that we've developed basically means that students from a high school need to get together, get a community effort to raise funds, locate a corporate sponsor, and get engineering support from that corporate sponsor. Because of the very tight time schedule of 6 weeks, the students really need all the support they can possibly get from either the school administration, teachers within the school, and a company, as well as they need a machine shop to help them build the robot.
Now, who can participate in this?
This is open to any school. It does take a little bit of time to probably pull it all together. Our season starts, the registration is in the fall and goes all the way through to the first week of December. And then right after New Year's, the first weekend in January, we will have a kickoff event. At the kickoff event every year, we hand out a kit of parts, which this year totals about 950 parts.
Whoa.
And then we also unveil the game. And the game is very different each year. And so at that point, every team knows what they have to work with and what they have to accomplish within that 6-week time frame.
All right, so they created, then they come there with a already assembled robot, is that correct? And then participate in some sort of game?
Yes, that's correct. The design build phase lasts 6 weeks. It will be ending this year on February 22nd. All of the robots must be delivered to a shipping company and sent off to drayage. And then we start the first full weekend of March having regional events. This year we have 10 events, and they're located around the country. The smallest event is 24 teams. The largest event this year is 72 teams, where these teams would compete in almost an athletic event with a radio-controlled robot. And the robot is actually out on the field with student drivers just off the field controlling the motions of the robot. And the robot must pick up objects, this year they're balls, and put them into a scoring goal area or block another robot from the other alliance from scoring against them. So the robot has to be designed for a very specific function, which changes every year.
Okay, and then, so it's not just the robot, but it's the agility of the master planner behind it, the person who puts it together or who manipulates the robot is critical as well. Is that correct?
Oh, absolutely. These teams will spend several days in the beginning. Frequently we find out that some teams, by the time the representatives that are here get home to, say, Texas or California, our kickoff event is on Saturday. A lot of the teams, the representative will not be home until Sunday morning. The teams have already constructed the playing field. We post all of our instructions and blueprints on our website, and these teams will look them up, and they will start building Saturday afternoon, and frequently we'll pull an all-nighter Saturday night to get the playing field. And then they start brainstorming, because strategy is a major part of the game. It's like any other athletic contest. You need to decide whether you want to build an offensive machine or a defensive machine. We put little tricks into the scoring field where this year you must either go up and over a 1-foot-high ramp, or your robot needs to fit underneath a bar that's 30 inches off the floor.
Whoa.
So if you build a robot that's taller than 30 inches, you have to negotiate the ramp. Otherwise, you can avoid the ramp, but the scoring mechanism has to reach about 7 feet in the air.
Wow, this is incredible. So this is also a problem-solving feat as well as mathematical and scientific.
Absolutely. These students will spend, several of the teams will break into subgroups. One group may be working just on fundraising, one on public relations. One group may just work on the drivetrain to just get a base that can be driven around the floor, while another group starts working on the strategy of how to score with the game and starts designing all of the mechanisms above the deck of the machine. So there's a lot of interaction going here. We provide computer-aided software so that they can actually design the entire robot on a computer and see how the various parts are going to function. That's included in what we give to the teams. So they spend a lot of time working on trying to figure out how this game's going to be played, and then they have to design the parts. Frequently, the first design doesn't work, so they go through 2 or 3 iterations. It's very similar to working in a manufacturing environment where you have to try things over and over again to make them come out right in the end.
Which is a really great plus in terms of trying to teach critical thinking skills, because most students don't understand that occasionally you do fail. And
well,
that
frequently
failure
we
is
find that students are not involved in an activity where they have a very, very tight time frame. So not only do they get into the engineering aspects of trying to design something that'll function, and then testing it and finding out that it cannot withstand the stresses that it's being submitted to, but they also need to understand that the entire process must be over in 6 weeks. And you have to work as a team because one person cannot do everything, and one person cannot make all the decisions. And so these students are learning a lot of other skills which are applicable to their situation in life in the future. We've also found that many of the engineers who work on this find themselves becoming better engineers because they also learn to work under a very tight time frame and to look at a variety of alternatives and evaluate them very quickly. So we do get feedback from some corporate sponsors that they feel that their engineers are better engineers after having gone through one of these teams and competing for 1 year.
Fantastic. Now, you talked earlier about fundraising. How much does it cost to be a part of this?
This year, the registration fee is $5,000 per team, and that includes approximately $1,000 for the control system alone, which we purchase on the outside. It's been designed to our specifications. So they would pick up the control system, and that's $1,000. The other $4,000 covers our cost for the procurement of parts and how we run the events, staff travel, and things of that nature here. We also do outside fundraising at a regional level to cover this. The $4,000, each team will get a piece of software, CAD software from Autodesk, which is worth on the market a retail of over $8,000. They will get about 950 parts, which is probably worth another $7,000 to $8,000. The controls, some handbooks and teaching aids. So they do get a phenomenal value for what they're getting. And then they also get to attend the event and have fun. And the events are very much like going to, a collegiate championship basketball game.
Now, I would say that most school districts can't afford $5,000. How do they get that kind of money to participate every year?
There are several ways we can do it. We have programs. We do have some support that comes through NASA. There's a grant that we have from NASA which supports quite a few teams. We do have some other corporations who are getting more and more involved, and will be adding their support next year, we hope. So we will be able to offer some teams kind of a scholarship to cover their registration fees next year. But most of our teams will form a partnership with a local organization or company, because not only do you need the money, you really do need to find some engineering support to help you out. So frequently these students will go and they'll have a corporate sponsor who will give them the financial support and the engineering support, and that covers the registration fee. They also need to travel to the regional, and frequently they'll have to stay 3 or 4 nights in a hotel. So there is some more money involved, and for that, most of these teams do local fundraising.
You are listening to Children Come First. This is Dr. Daria Brzezinski. This is 7:50 a.m. on your radio dial, WAAT. We're here every Tuesday, and we're here today with FIRST, FIRST, which stands for Inspiration and Recognition of Science and Technology. And we're here with part of that team, Bob Hammond, who's Executive Director of Robotics. Bob?
I'm the Program Director for the Robotics
Program
competition.
Director. And Bob, this is mainly a program that's being broadcast in Pennsylvania and New York. Where can people find out about information about FIRST in Pennsylvania or New York? I noticed that there are a large number of teams in Pennsylvania and New York.
That is a very strong region for us, and probably the best place to get information about FIRST and the robotics competition, as well as the other programs offered by FIRST, is from our website, which is www.usfirst, that's one word, .org. And there's a tremendous amount of information, including the schedule for this year's competitions, where they're located, and there's detailed agendas for each day of the competition, so that if people wish to come to a competition, they can verify the schedule and see exactly what will be happening during the time they're there. All of our competitions are open to the public. There is no charge. We feel that it's in the best interest to just have people come and see what's going on. And usually people are just totally thrilled to see what young students are doing in this competition. It really is incredible what these students dream up and then design and fabricate. In the area that we're talking about down in Pennsylvania, we have our Philadelphia regional competition, which is March 23rd to 25th of this year. That's held at Drexel. And the Thursday will be basically some practice rounds held during the day. And then Friday we will start team qualifying rounds, which will last all day Friday and into Saturday morning. And then at noon on Saturday we will take the top 8 qualifying teams, and each one of them will pick 2 partners to advance on with them. And the top 8 alliances will move into a double elimination finals round on Saturday afternoon.
How many students are on a team?
That fluctuates. We've actually had some teams that only have 5 or 6 students. We have teams that have 60 students. The average is probably in the range of 35 to 45 students per team.
Okay. What kinds of students participate? Basically, I'm sure these are all high school. Is that correct?
Right now, almost all of our teams in the robotics competition are high school students. We do have several middle school teams. Some of the regions just got very excited, and some middle schools decided they wanted to try and compete with their bigger high schools, and they actually have been very successful. But I think probably 99% of all the teams are high school teams.
How does this program work, or have you ever utilized it with regard to students who are troubled students, at risk is what we call them?
We do have several teams that come from inner city schools, and we obviously are trying to attract more minorities and more inner city school teams because we feel that it does generate an interest and stimulate the students from schools to look at careers that many of them don't consider. And we do have some very nice success stories. We also have had some schools or some teams that came from non-school settings, and one of the more interesting ones last year was actually a team made up of some gang members where their parole officer tried the program as almost a last resort, and they were very successful.
What state was this in?
That was in California.
Uh-huh.
Oh.
I'd like to know, if you wouldn't mind, if you'd send me some information about that. I work with the prison systems here, and I'd really love to have some information on that.
Yeah, it was a great thing because it was actually 2 gangs that were fighting each other on the outside, and the parole officer just kind of said, "This is the last resort. I'm trying to get these kids to work together and see something better than what they're seeing." And they actually did bond together and form a solid team. Not sure how the outcome will be over the long run, but for a while they did settle their differences and work together to build a robot and compete with it. And as I said, that was last year, and they were a very successful team. This year we have teams coming from Hawaii. We have teams coming from Alaska. The Alaskan team is made up from 2 schools that normally compete against each other in sports, but for the purpose of the robotics competition, they've merged their efforts into just one team. We also have teams from Puerto Rico, several from Canada, and this year we have one coming up from Brazil.
I noticed that many of the sponsors for the teams are, NASA is an obvious one, but Neutronics and Xerox and automotive centers, Chrysler. How can I know that people are going to think that the $5,000 fee is a lot, but I guarantee you with the kind of project that this is, it's really not a lot in comparison to what students are getting. How would they approach a sponsor? Who should they think about going to if they consider doing this project?
I think the first step would be to, and this is a good time for this show to be aired, because the first step would be to probably work with a teacher and a school administrator and convince the school that this is a worthwhile program. Again, I'd say hit the website, usfirst.org, see the schedule, and try and get to an event nearby. And for Pennsylvania, we have the one in Philly, but we also have one in Rutgers, New Jersey, and there's another one out on Long Island, which is, a fair drive. But the New Jersey and the Philadelphia ones would be fairly close by. Try and get to an event and see what you're actually getting into, because it is a major undertaking. And then at that point, I think you would try and find a local company who has some engineering talent available, because you really need to find a company who is willing to give up an engineer for several afternoons a week during this 6-week period, and hopefully these companies will see the long-term benefits to this. We, again, over and over find students who really didn't understand what engineering was, had obviously then no interest in going into engineering, worked with this program, fully understand what engineers do and how they work, found it fascinating, and started pursuing careers in engineering. But it does take the partnership of the school, which means the administration and at least one faculty member, and then some sort of a corporation nearby. And we do have teams that are partnering up with universities, and they're using the engineering school at a university.
Oh, there's a great idea.
Mentors.
Now, when you you go to the regional, and if you win at the regional, then what happens?
Well, each regional stands by itself. We do have a national championship, but due to the timing, you do not have to win one of the regional events to go to the national championship. This year, we have 375 teams, and 255 of those are going to the national championship. They do this for several reasons. The national championship is held at Epcot down in Florida, and it's held the first week of April, so it's obviously a nice time to go down and get some sun. They also do it because the competition level and the energy level at the national championship is very, very different than any regional. The national championship, we will be running 4 separate fields, so there'll be 4 matches going on simultaneously. Again, 255 teams. We anticipate about 18,000 people down there participating, which I believe makes it the largest non-Disney event held on Disney property.
Wow. Does Disney sponsor it at Epcot?
Disney does sponsor us very, very significantly at Epcot. They provide a tremendous amount of resources for us down there. The fields, all the tents and air conditioning, and so they give us a tremendous amount of sponsorship and help us out. It would not be possible for us to do that type of program without that commitment from Disney.
Now, for our first half hour, we have been speaking about Lego. We have been talking about the FIRST Robotics, and FIRST again being. Tell our audience what FIRST stands for.
For inspiration and recognition of science and technology.
And mathematics as well. And there is also, basically this competition, the robotics competition, is designated for middle school, high school students. Now, is there anything in your organization for elementary level students?
Yes, we do. As of 2 years ago, we saw the need to start bringing younger students into this type of program. Specifically, because engineering schools require a solid background in math and science in order to be admitted, we need to encourage students to take a look at science, technology, and mathematics earlier in their academic career. The answer to this was partnering with Lego, who makes the Lego Mindstorms kit. And so FIRST formed what we call the FIRST Lego League, and that is directed at middle school students. We had a pilot 2 years ago, and in 1999 we kicked off our first season. The pilot program had approximately 200 teams, and the initial year we had 1,000 teams compete in that program from around the country.
You are listening to Children Come First. This is Dr. Daria Brzezinski. We're here every Tuesday, 7:50 a.m., WAAT on your radio dial. We're here today with FIRST Robotics for inspiration and recognition of science and technology, and we're here with Bob Hammond. He's speaking to us about the incredible integration of mathematics, science, and technology in their robotics contests. And you can reach us toll-free, 877-PRO-KIDS. That's 877-PRO-KIDS. Or our internet access, PRO-KIDS at rlc.net. That's PRO-KIDS at rlc.net. Would you give us a phone number, Bob, where people can reach you if they have any questions?
Absolutely. We are up in New Hampshire, and we have an 800 number also. Our toll-free number is 800-871-8326.
And again, that's 1-800-871-8326. And Bob's extension is 404, if you'd like to reach him. Now, in our second half hour, I'd like to, if you will, Bob, speak to us a little bit about the Legos. And I know we were supposed to have the lady from the Lego League there. However, she was ill today. So we're going to try and wing it through talking about the Lego League. Join us for our second half hour. We're going to take a little bit of a break for our sponsors.
Very significant involvement from Cub Scouts, Brownie packs, and/or Boy Scouts and Girl Scouts, boys clubs, girls clubs. Homeschool groups are getting involved with it. We've had some homeschool groups that were very successful with it, and in some cases it's just a community, whether it's a youth group in the community or some sort of a community center that gets involved as an after-school activity. And with this particular program, you probably only need maybe 3 weeks of preparation to get involved with it. And then we have regional tournaments held around the country. And we had statewide tournaments this year in 9 states. And our goal is obviously to spread that so that we have state tournaments in all 50 states over the next few years.
So there's not a regional, there's just a state tournament.
No, this one is, we just have a state tournament. And we do have some areas of the country where there was so many teams participating that they literally had regional tournaments within the state just to somewhat qualify to get down to the states because the response was so overwhelming. We had hoped to hit 1,000 teams, but realistically weren't sure that a 500% growth rate in 1 year was something that we could attain. And the response, again, was absolutely overwhelming.
Now, are there teams in Pennsylvania?
Yes, there are. I'm not sure how many, and probably get the statistics. And Pennsylvania would be a wonderful state to, especially with the reputation of Pittsburgh becoming Roboburg, to develop a program. And we're working with some universities out in Pittsburgh to try and get a regional event there next year.
What did you mean by Pittsburgh being Roboburg?
Oh, Roboburg, Pittsburgh is developing a reputation for being the educational center for robotics engineering. And there is a group out there that is really trying to advance Pittsburgh's reputation in that field.
I didn't know this.
Yeah.
What I have is I have the 1999 FL Lego League tournament sites, and it's Alabama, Alaska, California, Connecticut, Illinois, Massachusetts, Michigan, Minnesota, and Ohio, but I don't see one in Pennsylvania.
No, we did not have a statewide tournament in Pennsylvania last year. I think that will probably be remedied in 2000.
It seems like
certainly hope so.
It seems like the alphabetical list of states went from A to O and missed several. I thought maybe you went to the first half of the alphabet, and next year you go to the second half of the alphabet. So there are 1,000 teams. Now, how can a school or an organization who is listening to this participate in the robotics? Do they contact Lego?
No, they would contact first at our website again, and the website is usfirst.org, and the person that they could email would be M. Baines. So it's MBAINES at usfirst.org, and Melanie would be able to send out information to anybody who was making inquiries into the program.
And what, now I know, what kinds of skills I know about my children were addicted to Legos. I bought thousands and thousands and thousands, literally, of dollars of Legos. They first started out when they were 4 and 5 years old building castles and worked their way up into the robotics, so I'm very familiar with all the different kinds of Legos there are. Does it take much to get a child who's 9 to 14 to be able to, is it basically the kind of Lego work that's been done over the last several years?
I think it is significantly. The major difference with this particular kit of Legos is the controller, which is, again, a very small computer which you can program, and you can hook it up to a PC and do the programming, and it's very visual on a screen. The kit includes sensors, several different types of sensors. One is a rotational sensor, which obviously could count the number of revolutions from a wheel or a gear. Another one is a time sensor, so that you can say go forward for X seconds. Another one is a touch sensor, which will sense when it contacts something, and another one is a photo sensor, so that the robot would be capable of following a line on a table.
How many people does it take to manipulate the robot, the Lego?
The Lego robot, a lot of the teams here were probably in the range of 6 to 10 students. Again, it's a team effort to build this thing and brainstorm. The beauty of the Legos, obviously, is if your design is not as optimum as what you want, you can take it apart and rebuild it fairly quickly. And we saw tremendous variety in what some of the students or the teams came up with for solutions to the problem. And again, here the problem will change every year. The other thing about the Lego program that we're working on with the first Lego League is that not only do the teams compete in a game, but we also give them a science problem. This year, it was basically the theory was that the space shuttle was stranded, and you had to build a robot that would go and rescue the space shuttle. And the reason the space shuttle was stranded was because some space debris had contacted the shuttle and disabled it. The students had to also present a hypothesis about what happened to that space shuttle. So it forced them to go out and do some research on space debris and on shuttles launchings and how much space debris there is up there, things of that nature. So it also brought the students into some real kind of research and or classroom work to learn something about a current event that's going on. And that will be very much a part of the program in the future, where not only is it competition with the game, but it's also competition on who can do their research and present the best hypothesis about the paradigm that's in the game, what's going on with the game.
How much involvement does NASA have in this project?
This one, NASA is, they support some teams. Their involvement is nowhere near as significant as it is in the high school robotics competition. Interestingly enough, I believe it was around 60% of all the teams involved with the first Lego League were actually sponsored and or coached by one of the high school team members.
Interesting.
So, yeah, what we're seeing now is the high school robotics teams are helping work with the middle school students and bringing the pool of available talent for the robotics team along and encouraging younger students to get interested. It also has helped us tremendously. We do have several teams that did not have freshmen in high school on the team in years past, and now some of the students who worked in the first Lego League have rolled into a high school team. So we're, again, reaching our goal of getting younger students involved with the programs.
Now, how is NASA involved in the older robotics?
Okay. This year, NASA is supporting us with 4 regionals where they have space centers. So they have provided funding, partial funding for the regional events in those space centers. And then we also were awarded a NASA grant to support 80 teams, 20 at each one of those regionals.
And where are those 4 space centers?
Okay, this year we are out in California, in San Jose, California, which is one of their centers. We are also in Richmond, Virginia at the Langley Space Center. We are working in Kennedy Space Center down in Florida, and we're also at Johnson Space Center in Houston.
Very good. So then what happens is that I think I'm a little confused here. These are specific regionals for those specific states, is that correct?
In the senior robotics competition, yes.
Oh, okay.
They are helping us with some support to start those regionals, and 2 of those regionals are brand new this year. The Houston we're going back into, we were not there last year, and then Richmond we're also going into this year. So NASA believes very strongly in encouraging more and more students to get involved with engineering. They obviously are having trouble finding enough engineers to keep their programs running.
Really?
And feel that this is one way that they can have more young people look at an engineering career.
Now, how does this translate, these programs, the Lego League as well as the Robotics League, how does this translate into becoming an engineer? Or in a science and technology field? Mm-hmm.
I think that in years past there were many students who, prior to participating on a first robotics team, did not fully comprehend what an engineer did. Several of them kind of said, oh, the engineer is the guy that blows the whistle on the train. But interestingly enough, once they work with an engineer hands-on and see how things are designed, how mechanisms are assembled, what makes them function, how you control them, all of a sudden they say, okay, I see how this thing, I now understand what an engineer is. I understand how, what they will do in their life. And people begin to say, this is fantastic. This is something that I can really get excited about. We get emails very frequently about young people who really, now that they understand what an engineer is and does, they've said, that is something that I want to do for life. And I think it obviously helps that there's obviously a very, very good market for engineers nowadays.
Now, how does this equate to improved science and technology skills, and mathematics skills as well?
I think one of the issues that we're seeing is that very few students in high school really see how they can use the mathematics. It's a subject that they take, and it's dry in some cases, and they don't see where it's applicable to anything they're going to do later in their life. By showing them how mathematics is a tool which is used by engineers, they then say, okay, now I understand why I need to learn some mathematics. Now I understand how it's used. Much of what we do in life doesn't require much more than just addition and subtraction, and maybe some multiplication, and people just use calculators. But to really understand what's going on when you design and or build something, you really need to understand that mathematics is a tool which an engineer uses to, it's just one part of a toolbox that they need to perform their job.
So, in other words, inadvertently, by working on these projects, students are acquiring skills in science and technology and mathematics that they wouldn't have heretofore been exposed to. Is that correct?
I think that's what we're looking at. We're not per se looking at teaching these fields. What we're trying to do is get students to see what these fields are like and see what happens when you're an engineer, and to get them to be inspired to look at engineering or science or mathematics as a career. Also, it's very important to have an engineer work with them, and so they fully understand what that engineer is and what he does.
Dan Golan, the CEO of NASA, said that students lack 7 different categories in his estimation from the educational process. One was that they have brain lock. Secondly, because they can't think in diversified ways. And secondly, they don't have teamwork. And third, I can't remember all 7 of them at this point, but another one was that they don't know how to fail, publicly fail, and go on to continue to work. And it would seem that this program certainly gives opportunities to students, both at the Lego level and at the robotics level, for students to be able to think in diverse ways. I mean, to build a robot, in my estimation, would take a tremendous amount of skill to create a robot itself, but to create one that does particular functions would definitely bring in many creative and critical thinking skills. And is this what Mr. Kamen had in mind when he created this?
Oh, absolutely. I think that these students have never been challenged in a manner that they will be challenged by this program. It's not just reading a book. It's not just memorizing something or learning something by rote. It's developing the fact that you need to have free thinking, you need to be able to brainstorm, you need to be able to listen to someone else's ideas. The idea of failure is very important, because I think it was Thomas Edison, when somebody said, you've had 1,000 failures in inventing a light bulb, he said, no, I found 1,000 things that don't work. And several of those things that didn't work for that application could very easily work for another application. What a lot of these students will learn is that frequently the first idea or the first thing you try will not work, and that you must persevere. And that's another thing that I think is missing in our society today. These students learn to work and work hard. Very frequently we hear about teams that need to be thrown out of school at 11 o'clock at night. They don't want to go home. They want to finish their robot. Most of our teams will work right through their winter vacation, and the team members will be in school for 10 or 12 hours a day during a vacation. It's that type of interest that we want to stimulate, and these young people are responding very positively. But again, they will learn that things don't always go right the first time, that you think you've got the problem solved, something breaks. You need to learn to respect that and get back up and start again and rebuild whatever broke, or redesign it, make it stronger, and move forward. These are a lot of lessons. So it is, the creative thinking, because these students have never been presented with a problem like this. The answer is not in a textbook. someplace. A lot of the principles are in a textbook, and the laws of physics are the laws you cannot break. But these students learn a tremendous amount, which is very applicable to what they do later on in their life.
Now, do you foresee this as getting larger, especially the robotics? And how will you handle the amount of people that will become involved in this? As you know, I'd like to get a tremendous amount involved in the state of Pennsylvania, and I can see this becoming huge. How do you propose to reorganize this when you have tremendous amounts of children involved?
The type of growth that we're seeing right now is presenting us with some very interesting challenges. We have 35% more teams participating in 2000 than we did in 1999. I would anticipate next year that we will hit 35% growth again. We are a very small organization. There's only 12 people on the robotics staff here in New Hampshire. So we count very significantly on a tremendous amount of volunteers around the country. Much of what we do is supported by regional committees who do a very significant share of the work that it takes to make this program happen. And I think that we will have to continue our dependence on volunteers, and probably to a much larger degree in the future. We need to duplicate the talents that we have up here in New Hampshire as far as putting on the events, and get more people out in the field trained so that they can cover events, and we can move our staff on to new areas and provide the growth so that the team here in New Hampshire covers the first year or two of an event and does some training with local people to get them so that they can carry the lion's share of the work.
In our last few minutes, would you like to summarize for us all the programs and where you're going in the future?
I will give it a try. It's been a very interesting program here at first, and we started with the robotics, the high school robotics competition. The first year there was basically 24 teams in a high school in New Hampshire, and the first 2 or 3 years it was touch and go, but it took hold. We picked up some corporate sponsorship. And as I said, this year we'll have approximately 375 teams competing. Next year we probably should be well over 450 and maybe up to 500 teams competing. The first Lego League, we think, will easily double next year, from 1,000 teams to 2,000, and could potentially go as high as 3,000. And then we also have a first place program, which is working on developing curriculum and doing some teaching aids and moving into that direction, because we've stimulated a tremendous demand in that area. So those are the three major programs, and I think that we will continue to take a look at what we feel are the needs that are not being fulfilled in the education field, and try and provide support for education and the development of science and technology and mathematics in this country. It's going to be tough. Again, we're a very, very small organization and stretched very thin trying to support all the programs that we're managing. But the need is there. The energy levels are tremendous. We have a huge core of passionate volunteers, which make things happen, because without that core of passionate volunteers, we would never be able to accomplish what we're doing today. For each person up here in New Hampshire that's working on this, there's probably 150 out in the field. Engineers that volunteer their time, teachers, school administrators, all kinds of people. And I think everybody just knows that there is a very strong need for us to motivate students to take a good look at engineering, science, technology, mathematics, and move into those fields we need to be able to compete with the rest of the world in technology, and that means in training and intellectual capital, and that's where we're going.
And this is another instance of how industry is assisting the schools to try and shift the direction and the format which we, in order to convey information to our students and about how children learn. And this is a really integrated system. We are talking about mathematics, science, and technology, as well as partnering with corporations, with the schools, with the parents, with professional people, and I think it's with the communities at large, and I think it's an outstanding opportunity for us to take a look at, and I really acknowledge Dean for his work here, because I think it's extraordinary for him to create something that is removed from the educational system per se as a day-to-day operation, and yet among the many of the projects that are going on around nationally, like OHM, the Odyssey of Mind, National Science Day, these are the kinds of things that are uplifting our children intellectually. This one specifically in science, technology, and mathematics, and teamwork, and critical thinking skills. And these are the kinds of projects that need to be incorporated in all of our schools, not just a few projects somewhere here and there, but in all of our schools. So I applaud your work, Bob, and I really appreciate your taking the time to visit us today.
Well, it's been my pleasure. As I said, this is a very exciting time. It's an exciting organization. I would like to take the opportunity also to thank you for having me on board and letting me explain our programs. I'd also like to thank our sponsors, because we have a phenomenal number of sponsors that make this whole thing possible.
And those are, NASA and the people, there are all different sponsors that you have.
I hate to even start listing them, but it's almost every major corporation, manufacturing corporation, healthcare. The list is huge, and it's what really makes this thing function. And again, some of the sponsors, it may be just a small machine shop that sponsors one high school team, but they're in it. They're in it for the right reasons, and again, they make it possible.
If you'd like any additional information on our broadcast today or any other broadcast, you may call us at 877-PRO-KIDS. That's toll-free at 877-PRO-KIDS, PROKIDS. Or you can email us at prokids@rlc.net. That's prokids@rlc.net. If you'd like information about FIRST itself, you can go to their website, which is usfirst.com.
.org, yeah.
.org, excuse me.
usfirst.org.
And you can call Bob if you'd like to, 1-800 at FIRST, 1-800-871-8326. That's 1-800-871-8326, extension 404, and that's Bob Hammond of the FIRST organization. And again, Bob, thank you so much for taking the time to be with us. I know it's an hour is an awful long time, and to do this program by yourself, so I greatly appreciate your taking the time and plugging in, even though Ann couldn't be here today.
Okay, Derry, I appreciate your having me on board the show, and I hope the listeners hit our website, find out when our event is happening near them, and go see.
And I'll see you in March in Philadelphia.
We will be in Philadelphia March 23rd to 25th.
And I'll be bringing my recorder and try to interview people for my broadcast.
Okay.
Take care.
Thank you very much.
Bye-bye.